recording locally on
Okay.
my
Okay.
machine.
And then I'm going to share screen. Okay. Really excited to see people here. Really excited. Thank you for coming. All right. So, kicking off week 1, quantum computers for fun. I don't know about you guys, but my friends and family said, you are so strange to have these kind of things as your hobby. Most people have things that are not as intellectually taxing, but what can I say? I proposed to my friend and colleague Jeremy to do a book club on this topic because I just finished participating in a book club that I loved, and it was very well run. So basically, I just copied the way that they did it, and hopefully, you guys will like it. The book club I just got done with was the O'Reilly book, Genomics in the Cloud, which if you have followed me, and I think a lot of you guys do on social media, you know that I'm working in bioinformatics. And so I just really learned a lot. And kind of a fun story about this book. I'm traveling around a little bit right now, and I was visiting my daughter in California, and I'm actually authoring an O'Reilly book. Just got started, and I went over to Sebastopol, where O'Reilly headquarters is, and there was like the one employee there, and I was excited. I don't know how excited he was, but they have sort of a library, and he said, okay, well, you take a book, and I said, only one, and so this was the book I took, and I started reading it, and then Jeremy and I work on other projects, and I said, I want to do a book club on this because this is an area I've been looking at and trying to understand for actually kind of years, and I just kind of can't get beyond the basics. And I learned so much in this Genomics in the Cloud book club that I want to do the same thing with a group of people. So that's kind of the inspiration. And I twisted Jeremy's arm, who was also interested in this. So the idea here is to have a 1-hour presentation every week on each of the 14 chapters, to record it, and then, kind of almost be like a college study group, work together to learn. We're all new, as far as I can tell. There's no quantum computing experts, although I did mention on Twitter and the authors did respond. Now, they didn't respond that they were going to definitely come in, but I would love to have them. When we did the Genomics in the Cloud book club, the authors actually took on some of the chapters. Now, the way that we envision this to go is we'll have this weekly 60-minute meeting with about half of it or 2/3 of it being presenting, and one person will kind of take the lead. So Jeremy or I, because we started it, we will take chapters. He's going to take next week. But if any of you would like to take a chapter, we would love that, because we were talking this morning and we said, wow, what have we got ourselves into here? So what we do is we prepare and then we practice present it to each other before we present it to the group. So I'll put like a grid up in the Slack, and if anybody wants to take a chapter, fantastic. If you don't, that's fine too. But that's kind of the idea. And then if we happen to engage with any people from the quantum computing community, I would love for them to be part of this as well. So that's kind of the idea. We'll have this, it'll be posted and recorded to YouTube in case you can't be here live. We have our Slack, which I think everybody's in. And I made channels for the book sections so that we can put our notes and stuff. And then we'll have these meetings. So the idea here is that we all are a bunch of nerds, and this is kind of a hot topic, and we want to learn together. And we're all going to be in different places in our learning. And when we do our introductions, maybe we can talk a little bit about that. If you're completely new, if you've, ever dabbled in this, because part of what I really got out of the other group was people had all different experiences. I am a really interested person in visualizations when I'm trying to learn new things. So I saw this visualization and I thought, oh, this really makes sense to me. So if you're new to this, it probably wouldn't make any sense yet. But along the way, we'll be working with a lot of visualizations. So talking about introductions, what I'd like to do is I would like to invite people, if they want to, just do a little introduction about honestly why you're here and what you want to get out of it. And I'm going to go last. So I'm going to stop the screen share and we'll just kind of go around. And if you don't want to, you don't have to, but we'd love to know like what you want to get out of this. So I'm going to stop the screen share and I'll invite Jeremy to go first, and then kind of everybody just call on the next person.
Sounds good. So I'm Jeremy Clark, and as Lynn mentioned, we work on some other things together. I've known Lynn for quite a few years, and it's great to work with her because we're kind of in different areas. I'm primarily in programming, and she's primarily in, well, she's cloud everything and big data and cool stuff like that. So I'm primarily in the teaching space these days. So teaching other developers how to get better. These days I'm doing .NET programming, so primarily in the C# space. And the quantum computing is something that's pretty brand new to me. I have a little bit of a science background, so quantum stuff isn't 100% new to me, but programming definitely is. So I like the idea of this book club because it's going to force me to learn. And so far, reading some of the chapters, it has taken a lot of effort, but I think it's similar to other times where I've taken on different paradigms of programming where it'll take a little while to kind of adjust and then get my brain into the right mode, and then things will start to make more sense. So that's what I'm looking for, and actually looking forward to, I should say. So that's why I'm here. I'm going to pass it on to Ken, if you want to go next, because you're next to me on my screen.
Sounds good. Hi, my name's Ken Sikora. I have been a consultant in software services really all of my career. My primary focus is on cloud, and like you, Jeremy, I also focus a lot in the .NET space, work a lot with Azure. I'm a member of the Azure user group here, shameless plug. It's a really awesome group. Anyway, I'm interested in quantum just because it's a space I've never explored. It obviously shows a lot of potential with a lot of claims around, being able to break, 2048-bit RSA keys and, fractions of the time of a traditional compute model. So it's something that I don't have a historically a super strong math background. My level of math when it comes to this stuff, like I did Calc 2 and Calc 3 in college, and that was pretty much like, I'm pretty much done here. So what I'm trying to get out of this is really a better understanding of what quantum does, how it can be applied in other spaces, and really learning what I don't know and what I need to know about it. Kind of, learn what I need to maybe understand, and hopefully go from there and see where it takes me.
I'll go next. My name is Kelly Kermode. I hail from Grand Rapids, Michigan, and I am currently working in a lot of the teaching space right now, training enterprise customers on cloud technologies. I'm interested in learning more about quantum computing. I've had a little bit of experience prior, just playing around with TPUs with regard to Google Cloud Platform and just seeing how those operate. So the explanation in chapter 1 felt familiar to me as understanding how those operate kind of as an additional processing unit, not your core CPU. But I'm happy to be here, and I'm glad that we're doing this. Obviously, learning has a big social aspect to it, so I'm excited to be part of this group.
Jump in. My name is Matt Pinner. I'm in Southern California, and been a developer my whole life. Eat it, breathe it, love it. Had all those types of jobs where you got hired for one thing, then it was something else once you got there. So you got to learn new languages, new paradigms. I've been in leadership for the last 9 years. I worked for a school district where we run technology for about 20,000 students. Has its own challenges, and I don't get to play as much anymore. So I get to watch my developer friends doing all the fun stuff, and we have a few developers in our group that I get to hand them stuff. But I guess the one part of it is my wife knows that I just need to take off my leadership hat and go play, every once in a while. So it's split time between my family and my kids, but I always find something cool. I didn't know much about microservices and stuff 2-3 years ago, so I jumped on board, and I just, after being in .NET for a long time, I said, let's go see what else is out there. Not to say anything bad about .NET, but I just want to see more of what's out there. Got playing with a lot of Google stuff and Firebase and Angular, and that was fun. I've got a Clojure book sitting on my shelf I haven't had a chance to open up yet, and I think my biggest issue is I've been fascinated in quantum computers just on the consumer side, on the technology side, and just really interested in it. And so when I saw Lynn's tweet or LinkedIn post, I don't remember which one it was, I was like, wow, here's an actual structured group that would help me set time aside to read and go through it with other people who are trying to do the same thing I'm trying to do. So from a computer person, I'm definitely excited to get my hands in it a little bit so I can really have a deeper understanding of it, even from when I read all the science fiction works and everything out there, really know what's going on behind the covers. And when I was in my engineering degree for years, it was fun that we were learning all the cool stuff you could do these days with amazing computers that, 20 years, 30 years ago, my doctor professors were saying, this was a little transistor and we had, 1,000 of them, and that's all we had to work with. And these were created with, substrates and all that stuff. And I feel like quantum computers in that pioneering stage. So even though we don't have high level languages and stuff like we're talking about, I feel like we're on that intro, and it's kind of exciting to be part of it. So that's me. And I'll pass it off to, I think, Danica.
Well, thank you so much, Matt. So my name is Danica Hannon. I'm a relationship manager with Cambridge Quantum Computing. So I've been working on moving into the industry for 5 years, and thank you, Lynn. Work finally paid off in February when I started this role. But the funny thing is that I really focused on learning the business side of the industry and learning the people and the culture. So I got the basics of quantum computing, but now the bill is due and I need to start learning the concepts a lot more deeply. So then I was at the Minnesota as your group last week. When I heard you talking about this, it was like, oh, perfect. And a shameless plug for me too. I'm a co-organizer of the Minnesota Quantum Computing Meetup. So really thrilled to be here with like-minded people. It's great to be with you all, and I'm very much looking forward to it. Gerard, off to you.
Greetings, everyone. My name is Gerard Bullhorn. I am originally from Haiti, and just like a lot of you, I have a background in .NET. In cloud solutions, this, just like a lot of you, or us, I should say, this is very new, but the promises of this technology are not just amazing, but there's a sense of hope with them. Just this idea of being able to, just recently I watched a video where they talked about how being able to mimic or simulate nature allows us not just the idea of control, but the idea of creating greater solutions that can at least mimic nature's mathematical perfection, if you want to call it that. And just this idea of creating solutions that involve so many factors at a wide range of subjects, that is truly exciting. And for me, the main reason I'm doing this is this hope that I'm sensing that quantum computing can bring. The end. Oh, did I have to pass it to someone? Daniel? Yes.
All right, there we go. Hi, I'm Dan. I'm still out in public, so I have to wear this thing. I am mostly a developer, .NET, Azure, and DevOps. I work at Land O'Lakes and that's the cows. And I'm interested in quantum computing because I don't like things I don't understand. And I want to understand this, so I'm on board. I gotta figure this out.
Fantastic. Thank you, everybody. I'm going to go ahead and screen share again. I really feel like I found my tribe. We are all a bunch of big nerds. Like, I'm serious. It's just crazy and great. I'm really happy that you're all here. Thank you. So how did I get into this? Many years ago, like 5, maybe 7, I was in the Toronto airport with another programmer, and there were a group of people that had these shirts on, and in the back of the shirts it said, "I program in quantum." And this person I was with was an extrovert and a nerd. And he just said, I'm going over. I don't care. And I was like, no, no, no. Well, long story short, they gave us access to their simulator. I really have to credit him because he just harangued them until they gave us access. So like 5 years ago, I got access to the D-Wave simulator. Didn't really kind of even know what was going on. That was my introduction. And started getting interested, just kind of like all of you guys, because it seemed to be the future. But I kind of went in, went out. I would read technical books about quantum. I would try things out. And I just kind of feel like I got to a certain point and I never got beyond it. One of the things that motivated me to grab the quantum book at O'Reilly is, as Jeremy was saying, I'm a cloud architect. I build solutions in the cloud, big data pipeline solutions. And the cloud companies now have quantum as a service. And to me, that's the time when I need to pay attention to this. So that's how I got into it. So speaking of D-Wave, I don't know. I think I can just go ahead and talk about this because you guys seem like you're big nerds like me. Even though we're going to be working at the software level, I need to know what the hardware looks like. So this is actually from D-Wave's documentation. And this is a picture of the inside of their one of their quantum computers. So you can see that you have these qubits, which we'll be computing on, that make up a quantum processing unit, or a QPU. And that's inside of this incredibly cold refrigerator unit. At the bottom of it is what D-Wave's quantum computer looks like. And again, they go right into it, as it says here. The D-Wave QPU is built from a lattice of tiny loops of the metal niobium, each of which is 1 qubit. Below temperatures of 9.2 Kelvin, niobium becomes a superconductor and exhibits quantum mechanical effects. Now, I, unlike some of you, did not study physics in college. So this is an area, as I continue to learn about quantum computing, I'm going to have to learn. We are not going to learn about hardware in this book club. The book doesn't cover it. But from some of my other studies and readings, there are a lot of different implementations of QPUs, and they matter. The software works differently on the different implementations, which is probably common sense to us. But because the book doesn't cover this at all, I just wanted to introduce this idea here, that we're focusing on software, but the hardware matters. Speaking of coverage, I also listened to several of the sessions from a Quantum Technologies online conference, which was free. Matt, I think you put the link in the Slack, and it's recorded, so you guys can go and see that. And it was really interesting because they focused a lot kind of on a different area of quantum computing. They focused at the top of my little drawing here in what I've labeled problem decomposition. What seems to be the case with the way people are actually using quantum computing is, it's like Kelly was mentioning, a QPU is kind of like a GPU or a TPU used in machine learning. It's part of solving problems. FinTech was one of the big verticals. Because I'm a real sort of practical gal, when I'm learning anything new, I always want to say, well, what would I do with this? And one of the situations about this particular book is it doesn't cover that. And so one of the areas I'm working on as I work through the book, which covers the areas that are shaded here, which is quantum operations or functions, and quantum programs or circuits, which are stringing the operations together to make programs. It has, those two areas are covered in good depth. Notice I've also included classical functions, because even in the quantum area, it's a combination of quantum and classical. So classical would be like print statements or if statements. So it's always this combination. However, these quantum operations and programs need to run on environments and on hardware. And so I really wanted to just share this because as I've gone through the book, although I really am happy with the coverage of operations and programs and circuits, I just wanted to share the fact that to further your knowledge, and an area that I'll be working on, is to continue to learn about environments and hardware, because it's as important as the software piece. So again, you can tell I'm an architect. I always have to draw a diagram. So in the book, it talks about what kind of background you need. And again, I've gone through the whole book once. I'm going through it again. Math functions, I think everybody has. One thing I would say is if you haven't done trig for a while, and it's not in the front of your brain, that you really are going to want to have trig kind of in the front of your brain. And a couple of ways to brush up that I use is I use Khan Academy, and I also use 3 Blue 1 Brown YouTube videos, Grant Sanderson, because they have great visualizations. So just a tip there. Converting between binary and decimal, I would think everybody could do. Comprehension of complex numbers, kind of the same as trig. If you don't do it every day, to me, it's not in the front of my brain. I know how to do it, but I will personally be using Khan Academy or 3 Blue 1 Brown. These concepts are important. And if you don't know them, it will be really difficult when you get into the later chapters. So the authors are serious here about knowing this. The programming side is pretty light. There's, as you'll see, many different programming languages that they have made available. They did a really good job with this. So you can kind of pick your language, that type that suits you best. The default is in JavaScript, which is kind of lightweight, which is good because you have enough to work on understanding the quantum concepts. So the first chapter covers a lot of the basic terminology. And to me, it's hard to just get terms when you don't have sort of like, I call it the clay or the program to work with. So in covering some of these terms, I'm actually going to take the first example from the second chapter, which Jeremy will present along with the other examples next week, but it's okay to hear things twice. Some, really basic ideas is a qubit is our unit of computation. Qbyte is 8 qubits. QPU is the quantum processing unit. So it's the, it's the physical processor. QC engine is a simulator, which the authors of the book wrote, and it runs a JavaScript language so that we can understand quantum computing concepts. QC engine cannot run on actual hardware. They have provided some alternative examples in different languages that could run on actual hardware. I don't really think any of us are at that state though, where we're building, production quantum code. So it doesn't matter that much at this point, but it's important to understand. And then there are some visualizers that are really going to help us. So what I really want to do in this week's chapter 1 coverage is I want to talk about programming environments because, the book is coding. And one of the things that you're going to want to do, if you haven't already, when you read the first chapter, is figure out which programming environment works best for you. If you don't have a choice, I would recommend the default. But because a lot of you have different language backgrounds, .NET in particular, you might want to do the .NET language, which is Q# versus the JavaScript. But in any case, I want to actually go and demo this because there are some things that are kind of fun about this. So this is a website, and it is it's an execution environment for the examples. So just some things, if you haven't gone through here yet, they have all the examples loaded. And when you pick an example, they show you which of the languages you can use. The default is their JavaScript QC engine. And then it's highlighted on the bottom in terms of which languages are available. You could also pick here. If you go to some of the later examples, you can see, for example, this one does not have this language available, which is called Circ. Most of them, they have all the examples except Circ. But, this is a way to, you can see this one only has QC engine, for example. So understanding how this programming environment works is kind of important. So of course you got the make it bigger, make it smaller. You have the list of different languages, and then they have the examples which load. And then when you want to run it, you just click run. And then you have 3 different outputs. You have the program circuit, which you can make bigger. You have the circle notation, which again, I'm not going to explain this. Jeremy is going to explain it next week, but you can start playing around with it. And then you have the program output if you have output that you've defined here. This particular program doesn't have any output defined. This is basically a print statement. To do that, you just do QC print, and then whatever the print statement is. What I did is to iterate on the code, and really all my other sort of notes for this, I put in a learning repository, and anything with the book, I put in book. And so, for example, because I never ever like to type any code live, which is the opposite of Jeremy, as you will find. He types all code live, which I guess he's a better programmer than me. So anyway, there's the print statement. And now if I run this, you can see. So this is basically just generating a single random value, a 1 or a 0. Now, one of the things that's going to drive all of you crazy if you're new to quantum is the whole idea here is that this is not deterministic. You see, I ran it the second time and it was a 0. That's the point. So I'm just telling you from the beginning, this is a new paradigm. Another thing that's interesting about this is this allows you to go through the lines of the code here, this program circuit. So if you click here, you can see that you see a certain activity, and you click here, then you click here, you see how the circles change. Now I know you don't really know what this means at this point, and then you can see there's a 0. Now if you go back and you click again, it changes to a 1. So this is kind of a debugger, but we're working in a non-deterministic environment. So again, it's not sort of what you're used to, but just think of it as allows you to work through the lines of code. So this environment, I would say by default, if you don't have another reason to use a different one, you'd probably want to use this environment. But we do have these other environments that you could use. So I summarized them here. This is not in the book, but I just thought I needed this for my own understanding. So QC Engine is JavaScript. It's written by the authors. The environment is the browser, and it has those visualizers, the circle and the circuit visualizers. The other languages have, they're based on other types of languages. So for example, if you're a Python programmer, you might like to use Qiskit or Circ. Qiskit is an IBM library, and it runs in a Jupyter notebook in an IBM environment, or really any Jupyter environment. Circ is maintained by Google, and it's based on Python. It's Python library, and it runs in a notebook. And I'm going to demo all these in just a second. OpenQ ASM is a C-style language. IBM, again, it runs in their environment, IBM Composer. And Q# is a Microsoft. It's a C#, F# style language. It can run in a notebook, or you can run it in VS Code or Visual Studio. And I'm going to show running it in a notebook. So it really doesn't matter which language you use. I do think, well, I know that I'm going to use JavaScript all the way through. We can discuss, like at the end of this, what you guys want to do, because maybe we can convince Jeremy to do Q# since he's a C# expert. I don't know. We'll see if he wants to do that. So anyway, so let's look at here. So if I go in here and I say, okay, this first program, I want to run it in Qiskit, and I click run, then it says you can do this using Open Qiskit. But what it actually is, if you qiskit.org, you'll see the program and you can see it's Python-like. But you need to run it in some sort of notebook. The easiest way to do it is the IBM Quantum Lab. And this is running in a Jupyter notebook with Python 3. And if you run it, you can see it generates a visualization that's kind of like this. But the book uses this program circuit. So again, if you decide to use Qiskit, this won't be exactly the same. So, I'm not sure who would really want to use this, but, I guess if you're an expert in Python and you want to use Python instead of JavaScript. So the next one is OpenQSAM, and OpenQSAM is, to me, looks kind of like C. So, and if you want to run this, it says you run it in the IBM Quantum Composer. And the Quantum Composer is kind of a more fancy version of what you see here. It's got visualizers. So I actually am doing this because this is the program here. And here's the program running over here. And you notice over here, if you click setup and run, then you're going to run it on a particular simulator, right? Let me kind of move all this stuff around so I can. So run. The thing that I really, really, really like about this, and I am starting to run some of the other samples on this, I'm trying to get this out of the way, is this Q sphere. Because in this environment, you got the circle notation, but the authors will tell you that you're losing some information because this is only 2D, because you're really calculating in a 3D space, and you can look around at this, which again, kind of being a little bit ahead of probably most of the group, you're going to want to be able to visualize what's happening in this 3D space, because we're going to be taking measurements out of this. So in some of the code that I'm struggling to understand, I'm running it in the IBM Quantum Composer, because this visualization helps me. And again, you guys may not be that into visualizations, but it's just something that really helps me. The other thing about this is it's really rich in terms of the information. So, and again, it's more mathy than maybe I even need, but it just is a really rich tool set.
I don't remember if it was chapter 2 or chapter 1, but what are the X, Y, and Z axes? Do you remember?
For where?
For the Q sphere, right? Like, I remember I was reading something like phase, I think is.
Yeah, again, let's.
Okay, because there's
I'm gonna table that question, because I specifically don't want to get into like the specifics. I'm really just looking at the environments, because we'll cover it. Great question, but I don't know offhand. I have to look, and I don't want to tell you the wrong answer. So, okay. So the next one is Q sharp. So for Q sharp, let me again move this stuff out of the way. If you want to run this, it says you can run it in online Q sharp notebooks, or you can download and install the Microsoft Quantum Development Kit, or the QDK. Again, I'm not going to do the Microsoft version, but because I have so many Microsoft and Azure people on the call here, and you guys just might want to, if you want to do it that way, great. I'm happy to play along. It's available, right? So if you go to the online notebooks, what happens is an interesting technology that I would bet a lot of you are not familiar with. There is this capability that you can put on a GitHub repository where you specify a path and you specify requirements. And then Google hosts this service. It's called Binder. And what it does is it looks in your repository for these requirements files. It looks for IPython notebooks. It creates a custom Docker container and runs it on Google Kubernetes engine. And they do it all for free. It has compute size limits, but the idea is to make runnable Jupyter notebooks. So you can see it's hub.gke2, so running on Google Kubernetes engine, my binder. Now, this is free, but it times out, because you kind of get what you pay for. So if I go in here to the chapter 2, this is a runnable Jupyter notebook with Q sharp with the examples. Now, runnable, yes, but the authors left something out here, because if I try to run this, it's actually going to give me an error. And this is something that I didn't finish, but I will add once I figure it out exactly. And the reason for the error, it has to do with the configuration. So you have to install the what's called the IQ Sharp extension for Jupyter notebooks in order to use Q Sharp in Jupyter. It's not super hard. I just ran out of time. Basically, you have to install the package manager, which is called Conda, and then you have to create a Q Sharp environment, and then the Q Sharp libraries will become available. So, and I'll put that into my repo once I get the exact steps. So there's 2 ways to run Q Sharp. You can run it in the notebook, or you can run it by getting the QDK and using like Visual Studio. All right, next one. The next one is Circ. Circ is the Google open source that's like Python. And if you run this, the instructions are kind of like non-existent, basically. So it just says go to the GitHub repo and, I don't know, figure it out. So I figured it out for you. So the easiest thing to do if you have this is Google has a similar capability to Binder. It's called Collaboratory or Collabs. And you basically just say file new notebook, and then you've got a Python notebook. And then what you need to do is import circ. And then once you import circ, then this is the actual example here. You can run the example. And I just laugh about this because the vendors are different. This is Google's idea of a visualization. They're such hardcore programmers, good enough, right? So I guess I would use this if I was working in Google Cloud or in the Google Cloud platform. For learning, I'm probably not going to, because I really want to use the richer visualizations. So it's going to be really interesting to see what all of us decide to use for our programming environment. Maybe during the discussion part today, we can share if you have an idea about what you're going to use. So, and again, these slides are up on my GitHub. So if you want them for any reason, you can just get them. So those are just the different environments. So we have Qiskit, which is Python on IBM Quantum Lab. We have OpenQASM on IBM Quantum Composer with the cool sphere, which I have to find out about the axes. We have Q# on the Jupyter notebooks, but we have to install that connector thing, or you can download it, run it locally. And then we have circ running on, I recommend Google Colabs. So kind of pick your language. All right, next up, because I said that the book doesn't cover hardware, I have been kind of taking a look at this. So in the world of Azure, what you have if you want to try to run this on Microsoft Azure is you have 3 actual providers, none of whom are D-Wave. And again, I caution you that their QPUs all run differently depending on the provider. But most probably none of us are going to use any of these actual hardware that you pay for by the minute, because it's ridiculously expensive, like $50,000 a month for the smallest usage. So I doubt it. So what would you use? You would use this simulator. So interesting that all these cloud vendors have the simulators, like Microsoft has this Q10 simulator, and Amazon has Amazon Web Services bracket, they call it simulators. Notice that D-Wave, or Quantum as a Service, is available in Amazon bracket. Again, it's shockingly expensive. So you'd have to have a really compelling use case. So Amazon has different hardware providers. They have D-Wave, they have INQ, Rigetti, and those are the providers they have right now. There are other Quantum as a Service companies out there. I just I'm looking at these two because, there's only so many hours in the day. So in terms of resources, obviously we have the book. I showed you my GitHub repo. Jeremy also has a GitHub repo that he's doing a lot of like kind of playing around with the code and when he's trying things out. And I really welcome if any of you, have any other resources that you're sharing, and I would invite you to put them in the Slack. So at this time, what I would really like to do is I would really like to kind of check in with everybody and just go around the thing and see what kind of programming environment that you guys think that you're going to be using. I'm just really curious. So I'll start. I'm using the JavaScript one, and then I'll hand off to Jeremy.
Yeah, I'm also concentrating on the JavaScript one, primarily because I really haven't looked at much of the other ones so far. I do like how you can kind of put the marker at different points in the circuit to see what the state is. That's actually been really helpful to me for learning what the different operations do and how they work together. I have been curious about Q#. I'll probably install that at some point. And then another thing is the IBM environment, in addition to having that cool sphere, is also a drag and drop environment. So you can actually drag the circuit pieces onto the circuit diagram to put things together that way if you don't actually want to type. So I think I'm probably going to be working primarily in the QC engine. That's where I've been doing a lot of playing. And then the IBM environment again, is kind of compelling as well. So I haven't looked at Q# yet, so I'm not exactly sure what the development is like in there, but I'll definitely take a look.
Yeah, I will probably follow suit and stick to JavaScript, given that my goals here are primarily just to understand quantum, not to apply it to my day-to-day life. But given that I spend some time in .NET, I'll probably tinker with Q# and maybe send a job or two to Azure to just see what the experience is like. Matthew.
Kind of like the rest of you, I'll probably stick with JavaScript. It's really easy to read. I know when I try out new technologies, learning the platform and linking all the libraries together is so much overhead that you actually don't learn anything until you wade through it all. And so seeing the size of some of those notebooks that you opened up, I'm like, wow, 99% of that is overhead. I just want to learn how to actually apply the knowledge and make use of it. I was intrigued by the IBM side of things, though. I do like the visualization as well. And already in chapter 2, that's as far as I've read, they talked about the different angles in the X, Y, and Z axis. And I'm like, there's no way I could tell anyway to apply that to your circle notation. So when we get there, I like the idea that you can see it in 3D somewhere. I was really impressed by their website, though. I've yet to see a programming book author have such a nice and easy to jump into polished website that makes it, I mean, half the books I've been reading lately, you've got to install so many NPM packages or Azure packages before you can even run the first line of code. And if it's 6 months out of date, there's already some errors that's been introduced. So I was impressed by their website. Throw it off to who's next on my screen. Gerard.
Okay, I'm unmuted. Last weekend, I started a TrueSite course, and it's on Q#. So I feel that I'm already on that bandwagon, so I'm going to continue. Interestingly, Lynn, you showed the Google one. I believe it's Circ, right? Circ. And there's something quite attractive to me in that very bare, unabashed simplicity. So I might take a look, but Q# is my home base right now. Or am I supposed to pass it to Carl?
Hello. I apologize for being a little late. I was having issues with allergies earlier today, so I took a nap and then I woke up and I'm like, oh no. But yeah, so I've been looking at Q# for a while. When I first started reading it, I just thought it was just kind of cute, the language, because I didn't really think there was anything behind it that was like meaningfully quantum, like it's just like a nice mental experiment, I suppose. But I didn't, like I mentioned before in the chat, that I didn't really understand the concepts. I've done a couple, I did like quantum physics in college or whatever, but it's like programming aspect, I didn't quite understand like how this all like kind of works together. But so I would probably just stick with the JavaScript for now, just to kind of like get an understanding of like basic concepts and how things are supposed to be, and understanding the notation of the little circles. But after that, I think I would really like to like get into Q#, just because it was initially what I like stumbled upon randomly. Like I feel like it was a year or so ago, maybe even further. But and knowing that it actually applies to something like meaningful, like on a hardware almost kind of perspective. I really don't know much about any of this stuff specifically in the hardware, and to me, I'm just like, I guess initially when I first started like reading about it, Q#, I mean, like I was just like, oh, this is a nice mental experiment for everyone to just kind of, like dream of a day someday when we were actually programming in this stuff. But I didn't think, like I wasn't sure if it had any actual practical implementation. So now that I see that there possibly is, I don't know, I'm like still in like the first few chapters of your book, so I still don't know really much more than that. So yeah, again, I'll probably be in the JavaScript for now, just so that I can like have a little string to grasp. And then we'll see. You know, I've always been told if you give me a finger, I'll take your arm. So right now the JavaScript is the finger for me. So yep, I'll pass it on to Danica.
All right. Lynn, I'm going to take your approach. I'm going to start with JavaScript, but the same as you read the book once and you read it twice to really get a mastery of things. I'll start with JavaScript. And I think as we go along, probably near the end, I'm going to go back and play with the Q# environment because the Q sphere really adds something. Daniel, on to you.
Yeah, I'll probably just do JavaScript unless I have a compelling reason to switch. Just easier to follow along, and you know, since the book is doing it that way, right? I might as well learn JavaScript way, you know. But if I build $1 million quantum solution, I'll have to investigate the languages more closely. Kelly?
I don't know if Kelly can answer because she's driving. So, so great.
Oh.
Well, so it sounds like JavaScript and Q# are kind of the top of the thing here. But when we get stuck going to the IBM Composer, that's a pro tip. So for next week, Jeremy is going to take the lead on presenting. I'm going to throw out there again. You can clearly see, and you'll see as we go along, that Jeremy and I are not experts at this at all. It can't, Carl. It's not our book. We're reading the book. We didn't write the book, so we're new too. So if anybody is interested in leading a chapter, and I really see this as, you know, a group discussion. It's not like you're the expert and we're going to, like, you know, we're all learning together. Just so you don't have to listen to us each time. Do you know what I mean? So if somebody wants to take a chapter, you really like a chapter, just I'll put a thing in the Slack. Like if you in a chapter you really like, you know, you can feel free to lead it, because we're all here to learn together. And again, we're always open for feedback. You know, I made this sort of introduction purposely kind of light, you know, maybe too light, I don't know. But again, this is a hobby. None of us are pro quantum programmers yet. So I didn't want to go like brain bendingly hard on the first chapter. So hopefully it was a good use of your time. So for next week, Jeremy will be leading on chapter 2. So if you have the chance to work through those exercises, that would be the focus area, probably in JavaScript. Oh, look, yay, Dan, he's going to go for chapter 3. Love it. Thank you. You know, then we will just kind of go week by week. When we're not meeting, post stuff in the Slack. I post actively to my repo, and I will post every week's meeting on YouTube. So if you miss a week, you know, it's not like, oh, you know, like I missed it, I can't come in. Just, you know, we're casual. So just come in when you can, because 14 weeks is kind of a long commitment. I kind of was laughing because I feel like we're accountability partners for nerd learning. That's really what it is, isn't it? Because I've had you know, for like working out or for nutrition or whatever, I've had this before, but I haven't really had this for nerd learning. So I'm really happy that you're all here.
Len, I have a question for you regarding the video postings on YouTube.
Yeah.
Would that be limited to the group or can it be shared?
What would you prefer? I am very much like, I'm an educator, so I'm like, I tell everybody everything, but I want to be respectful of people's preferences. If you would like the videos to be unlisted so that, you know, you'd have to have the URL, if you would prefer that for privacy, whatever you guys want, I don't care.
Well, I'm quite proud of the group, so I wouldn't mind just sharing.
Okay. Is everybody, thank you. Is everybody okay with me just posting this to public YouTube? Is that, if you're not, just let me know and I won't, because like I want everybody to be comfortable. But I'm a big educator. I'm like, everybody should learn, everybody should come, everybody should, you know what I mean? So that's what you get with me. So
thank you, Lynn.
Yeah, for sure. Is there any questions about what we're doing here, or any suggestions to add other things?
I would just say thanks for setting this up and running it. I am trying to run a book study with my own team and then educators up and down Southern California for Phoenix Project and stuff. And I don't know how to do that in a virtual sense. So I'm taking lots of notes about how you're running this. So.
Well, I told you, I just completely copied what this guy, KT, I forget his last name, did for the genomics in the cloud, because I loved it. I was like, oh, I just want to do this. And so no credit to me, that I really like the Genomics in the Cloud book club. So I just would say too, for those of you who haven't read the book once yet, when you get to the point where you're reading something and you just read it and it like, whoop, and you read it again and whoop, we can commiserate and I'll say, I didn't get that. I did not get it. Because there's big parts of the book, I cannot get it. And I'm just like, I hope in this group, I can figure it out by working together, because it's kind of hard to come through it and just go, wow, am I just not capable? I mean, it sort of tests your confidence. So be ready, people. This is some, if you're feeling like, I think I'm gonna have to quit. I'm so embarrassed. I don't understand any of it. Nope, we'll get there. We'll get there together. It's kind of like climbing a mountain. Right now I'm in Utah and I'm struggling with the altitude. And I kind of feel like it's like riding my bike around in Utah, where I kind of like, okay, I got to stop and take a breath here. That's kind of how this is going to be, I think, for us. But maybe it's just me. I don't know. Anyway, I'm really glad you're here. Unless there's any other questions, I look forward to this journey we're going to be on. And, it's going to be on Jeremy next week, so you don't have to listen to me.
I just wanted to say that I'm kind of obsessed with Utah right now, because I've been watching this YouTube channel called Matt's Off-Road Recovery, and like it's just so beautiful. All the different terrains and all the fun stuff that people can do out there. And I'm just like, someday I'm gonna build my truck so that I can go get so that man can rescue me.
Well, here's a funny thing.
It's a fun. Oh, go ahead. Sorry.
Here's a fun quantum thing to end the day with. So I'm staying in an artist's loft in Utah. And so see the Vespa, the motorcycle in the background?
Yep.
Quantum. Is it art or is it transportation? We're such nerds, right? We're such nerds. I think we have to stop. Anyway, really great to meet all of you. Really looking forward to this journey. I'm going to go ahead and stop this recording and I will see you all next week. All right? Take care.
See you, everybody.
Okay, bye.